cell potential. In a voltaic cell, the cell potential is defined as the electromotive force which tends to cause a current to flow of a cell built of 2 electrodes. And it is referred to the energy that is available to do work of moving a charge in the form of the electron between the 2 electrodes. And the SI unit for this electrical potential is volt, and for the electrical charge, the unit is coulomb. Okay, this voltaic cell work due to the presence of the spontaneous reaction that is occur as a result of different ability of the materials such as metals or other non-metals to give up their electrons and to receive the electron, and their ability of the electron to flow through the circuit. The E cell or the cell potential will be greater than 0 if the reaction or the redox reaction is a spontaneous reaction and process. However, if the E cell is less than 0, means that the reaction does not occur spontaneously. So 1 volt is equal to 1 joule per coulomb. This is the voltmeter that is measuring the cell potential between the copper and zinc. So the calculation of the cell potential can occur in 2 conditions. It's either the process is at the standard condition or the process is not at the standard condition. So the standard condition is when the aqueous solution 1 molar. The pressure is 1 atm. Temperature is at 25 degree. See, these are the standard condition. So if the system is at the standard condition, to calculate the E cell or the cell potential, we are using this equation E naught cell equal to E naught cathode minus E naught anode. This naught symbol shows that this process is at the standard condition. As if the system is not at the standard condition, any one or two or all are not following the standard condition. For example, if the concentration is not 1 molar, the pressure is not 1 atm, or the temperature is not at 25 degrees C, then the cell potential that is calculated is using Nernst equation. So Nernst equation is E cell or cell potential is equal to the standard cell potential E naught cell minus 0.0592 over N log Q. Q is the ratio of the concentration of the products over reactant as what we have calculated in equilibrium. Let's calculate the unknown E naught half cell from the E cell that is given. A voltaic cell has the reaction between aqueous bromine and zinc metal. The equations is given when bromine plus zinc produce zinc 2 plus 2 Br minus. So from this equation, it is obvious that bromine undergo reduction. As the oxidation number here is 0, it turns to negative 1. So the oxidation number of the bromine decreases, so Br undergo reduction. And when we look at to the zinc, the oxidation number of zinc is 0 initially, then it is turns to plus 2. So oxidation number increases means that zinc undergo oxidation. We know that the reduction is always occur at cathode. So this is what will happen at cathode, the reduction of the bromine, and the oxidation is always occur at anode. So the zinc undergo oxidation at anode. And then the question told us to calculate the E naught of the bromine when the E naught zinc is given and the E naught cell is also given. So we are using the normal equation, which is E naught cell is equal to E naught cat minus E naught anode. Okay, so E naught cell is given as 1.83 volt. E naught cat is the E naught of the bromine. That is what we want to calculate. Minus E naught N, which is the E naught of the zinc, that is given negative 0.76 volt. So we can get the E naught of the Br is equal to 1.07 volt. Okay, so when the reaction occur at the standard condition, we can use this equation. Okay, it's either the E naught cell need to be calculated, E naught cat and E naught N is given, or the E naught cell is given, E naught cathode also given, and we have to calculate the E naught anode. Just rearrange the equation. If we change the concentration of the components of the system, it will give effect to the cell potential. So the cell potential will be different from the standard cell potential. Okay, so when the system is not at the standard condition, we'll use this Nernst equation, which is E cell equal to E naught cell minus 0.0592 over N. So this 0.0592 is actually come from RT over F. Okay, log Q. Q is the reaction quotient. So if we change the concentration of the components of the system, it will change the Q. So if let's say we have a reaction of A aqueous produce B aqueous. At the standard condition, both of A and B need to be at 1 molar. If we change the concentration of A and B, for example, if A is 0.5 molar and then B is 1.2 molar, okay, it will make the Q that is initially (1 over 1) equal to 1 become different, and in this case 0.5, the Q will be greater than 1. The Q also can be less than 1. Okay, so if the Q is less than 1, the reactant's concentration is greater than the product. Okay, and it will make the log Q is less than 0, so that the E cell will be greater than E naught cell. Okay, this is how we predict. If Q is less than 0, log Q will be less than. If Q is less than 1, log Q will be less than 0. E naught will be greater than, E cell will be greater than E naught. However, if the Q is equal to 1, means that the log Q is equal to 0, E cell will be the same as the E naught. As if Q is greater than 1, the log Q will be greater than 0. Therefore, the E cell will be less than the E naught cell, standard cell potential. This is how we predict what is happened if we change the concentration. Look at to what happened at the Q, and we know what is happened at the E cell. Okay, let's try to apply Nernst equation to calculate the E cell. Okay, so in a test, we have a voltaic cell that is contained or consists of the zinc and zinc 2 plus and H2H plus. So if we write the standard reduction potential that we have in our tutorial workbook, okay, the H plus reduction equation will be 2H plus aqueous plus 2 electron produce H2 gas. The E naught is equal to 0.00 volt. As for zinc reduction, zinc 2 plus aqueous plus 2 electron turns to zinc solid. The E naught that is given is equal to negative 0.76 volt. Okay, now we have to predict which one that will be at anode and which one will be at the cathode by looking at the E naught value. So the more positive or the less negative the value, the more readily the reaction to occur. Or the more negative the value, the more readily the oxidation to occur. Therefore, the one that will be reduced is the H plus, and it is occur at cathode, and the one that will be oxidized is zinc. So the process occur opposite way. Okay, so it will oxidize at anode. The question also told us that the concentration of the zinc 2 plus is equal to 0.01, H plus is 2.5, and H2 is 0.3. It means that the concentration of all components are not at the standard concentration. Okay, so when the question asks us to calculate the E cell, we know that we have to use the Nernst equation. So let's look at the Nernst equation. E cell is equal to E naught cell minus 0.0592 over N log Q. Okay, so what are the components that we have to calculate? First, we have to determine what is the E cell. Second is we have to know what is the N is the total number of electron that is transferred during the process. And then Q is the ratio between the reactants and products concentration. Okay, so let's write the overall equation first. Since that zinc undergo oxidation, let's reverse the equation. Equation will be zinc solid turns to zinc 2 plus 2 electron. Okay, so the overall equation will be 2 electron, so 2H plus aqueous plus zinc solid turns to H2 gas plus zinc 2 plus aqueous. Okay, let's calculate the E cell. E naught cell. Okay, let's calculate the E naught cell. E naught cell is equal to at minus E anode. So it is equal to E naught cathode is 0.00 volt minus negative 0.76 volt. E anode is equal to positive 0.76 volt. Okay, so we complete the first components. The second one is we have to identify what is N. So by looking at this balance equation, our N is 2, since that there are 2 electrons that is transferred during this process. So N equal to 2. The next step is to calculate Q. So Q is equal to, from the balance equation, is the concentration of the zinc 2 plus, concentration of the H2 over concentration of the H plus power of 2. So it is equal to 0.01 multiply with 0.3 over 2.5 power of 2. And we'll get our Q is equal to 4.8 times 10 negative 4. So now we can plug in all the values into our Nernst equation. So E cell is equal to E naught that have been calculated, 0.76 volt minus 0.0592 over 2 electron hour n log 4.8 times 10 negative 4, and finally we get the E cell is equal to 0.86 volt. So this is how we use the Nernst equation to calculate the cell potential that is not at the standard condition.